Hi everyone, so in this video we're going to be going over simple and stock dilutions, and we're going to go over everything that we have to know about them for this class, so the concepts, how to calculate them, and how we can actually apply them in the lab. So to begin, what is a dilution? Well, a dilution is defined as the process of reducing the concentration of a solute in a solution, and this is achieved by the addition of more solvent. And we have our universal solvent of life, our water. We're going to most commonly see water as our solvent, but we can have other solvents, like for example, buffers. Buffers are a solvent. And dilutions, they are everywhere in science and in medicine. So, for example, in medicine, dilutions, we need them to make sure that we can reduce the concentration of our antibiotics and our drugs so that they're safe and precise for the specific patient. Even our IV fluids like saline and glucose, we dilute them to be at the right concentration for our specific needs. In chemistry and industry, these dilutions, they are necessary to make sure that we can carry out appropriate chemical reactions, and they're going to adjust the potency of cleaning agents. But it doesn't matter the field that we're using dilutions in. They are super necessary for achieving results that are not only safe but also reproducible. So the formula for dilutions is displayed here. It's C1 times V1 is equal to C2 times V2. And C1 is always going to be the initial concentration of our stock solution. V1 is going to be the initial volume of the stock solution. C2 is our final desired concentration. And V2 is our total final volume of the diluted solution. And this formula is going to just make sure that the amount of solute remains constant before and after dilution. So let me write that down. The amount of solute needs to remain constant before and after dilution. We can think about it like spreading the same amount of solute across a larger volume. So now we're going to get into what simple solutions are. So simple solutions, they are one of the most basic and yet essential techniques that are going to be used in the lab. And a simple dilution is going to reduce the concentration of a solution by adding solvent. And this is often expressed as a ratio, such as 1 to 10. And what this means is that we're going to have 1 part solute to 9 parts solvent. But no matter the ratio, whether it's 1 to 4, 1 to 8, 2 to 6, it's going to be parts solute to parts solvent. And these simple dilutions, they are commonly used to prepare solutions for experiments or to make concentrated chemicals more safe to handle. So now that we know what simple dilutions are, we're going to go over a few key terms that we need to know for them. So in the lab, often we're going to be given a stock solution, and then we're going to be asked to prepare a lower concentration solution. And our concentrations, they can be expressed in 2 ways. They can be expressed in percent weight per volume, or it can be expressed in molarity. And so what happens with percent weight volume is that it is the percentage of the solute's weight in the total solution volume. So this is the percentage of the solute's weight in the total solution volume. And these concentrations can also be expressed in molarity, moles. And this is just the number of moles of solute per liter of a solution. So for example, we might be asked to prepare a solution for an experiment from a concentrated stock, which is what we see, which is when we're going to have to solve for V1. And the way that we solve for V1 is by rearranging our dilution concentration. So what's going to happen is that we have our C1 times V1 is equal to C2 times V2. And when we divide by C1, we're going to end up with the formula V1 is equal to C2 times V2 over C1. So, for example, we have been given a stock solution of 2.0% dextrose, and we need to prepare 10 milliliters of a 0.1% dextrose solution. So the first thing that we have to do is write down the values that we know. So we know that C1 is always going to be equal to the initial stock concentration. And we're told that we are given a stock solution of 2.0% dextrose. So our C1 is going to be 2.0%. And it's asking us to prepare 10 milliliters of each of the following solutions. So 10 milliliters, that's going to be our final total volume. 10 milliliters. And we have three different desired concentrations. We have 0.1%, 1.0%, and 0.5%. So that leaves us with how much stock do we need? We need to solve for V1. So this is when we have to rearrange our formula, and our formula becomes V1 is equal to C2 times V2 over C1. So from here on out, it's plugging in our numbers. So like I said, we know that we need 2% for our initial volume. Our total final volume is going to be 10 milliliters. And then our desired concentration for this specific part is going to be 0.1%. And we need to solve for V1. So now we just have to plug and chug. 2.0%. We're going to put 0.1%, and we're going to put 10 milliliters. When we put it into our rearranged formula, we get 2.0% down here, 0.1% up here, and 10 milliliters up here. So when we plug in the numbers and we do all the math, we see that our percentages are going to cancel out, which is going to leave us with our unit of milliliters. And when we do the math, we see that our V1, so the volume of stock that we need, is going to be equal to 0.5 milliliters. So now that we know how much stock we need, we now need to solve for the amount of water that we need. And the volume of water needed is expressed by the formula V2 minus V1. So our final total volume minus the volume of stock needed. So we know that V2 is 10 milliliters, and we know that V1, because we just calculated it, is 0.5 milliliters. So 10 minus 0.5 is equal to 9.5 milliliters. So it is going to take a total of 0.5 milliliters of stock solution, our 2.0 dextrose, in order to get so it's going to take 0.5 milliliters of our stock solution, and to that we have to add 9.5 milliliters of water, which is our solute, to prepare our 0.1% solution. So now we're going to build on this and look at how we can prepare other concentrations. So for this specific example, the only thing that's going to change is that we now want to prepare a 1% dextrose solution. And when we plug in our numbers, we get that V1 is equal to 1% times 10 milliliters over 2%. And our final answer is 5 milliliters for V1. We still need to solve for the volume of water needed, and we also get 5 milliliters. So what do these results tell us? These results tell us that we need to mix 5 milliliters of our stock solution with 5 milliliters of water to prepare our solution at the desired concentration. And we see the same thing happening for this next example, in which the only thing that changed was the desired concentration that we need. So when we do the math, we see that we end up with a total of 2.5 milliliters of stock needed, and when we obtain our volume of water needed, we have 7.5% milliliters. So what does this mean? It means that we need to mix 2.5 milliliters of stock solution with 7.5 milliliters water to get our desired concentration of 0.5% in 10 milliliters of water. So now that we've gone over simple dilutions and how to solve for them, we are going to look at a little bit of a more complex example, and these are called maximal dilutions. So maximal dilutions are going to refer to the highest possible dilution that can be achieved while maintaining accuracy. So this is really important. We need to maintain accuracy in our maximal dilutions. And we need to remember that we cannot prepare a solution with a concentration higher than the stock solution through dilution. Dilution can only reduce our concentration. It cannot increase our concentrations. So we are going to go over this example, and what this example is asking us to do is prepare 25 milliliters of a 15% dye solution, beginning with a 20% stock dye solution. So let's rewrite this. We know that we have 20% stock dye, and this is going to be our initial stock concentration. This is going to be our C1. And we have to prepare 25 milliliters of solution. So this is going to be our V2. This is going to be our final total volume. And we know that we have to prepare a 15% solution, which is going to be our C2. So again, we're left with solving for V1. And the formula to solve for V1 is V1 is equal to C2 times V2 over C1. So when we plug and chug, we get that V1 is equal to 15% times 25 milliliters over 20%. So now we're actually going to solve this formula, this equation. So what happens is that we have our C1, which is 20%. We have our C2, which is 15%. And we have our V2, which is 25 milliliters. And it's important that we convert our percentages to decimals just to simplify everything. So in order to convert 20% into a decimal, we have to do 20 over 100, which is equal to 0.20, and we have 15 over 100, which is equal to 0.15. So when we rewrite the equation, what we get is 0.20 times V1 is equal to 0.15 times 25 milliliters. And when we multiply 0.15 times 25, we get 3.75 milliliters. And when we divide that by our C1, which is 0.20, we get a total of 18.75 milliliters. So the volume of stock needed is 18.75. The next thing that we have to do is calculate the amount of water that we need to add. So we have to do our V2 minus our V1. So when we subtract 18.75 from 25, we get 6.25 milliliters of water needed. So how we read this is that we have to mix 18.75 milliliters of our 20% stock dye solution, which is our initial stock concentration. So we mix 18.75 milliliters of our 20% stock solution with 6.25 milliliters of water to obtain a total volume of 25 milliliters of a 15% dye solution. So something that we always need to keep in mind when we are going over maximal dilutions is this very important concept. And this concept is that we cannot dilute to a higher concentration than the stock solution. So we cannot dilute to a higher concentration than the stock solution. We cannot dilute to a higher concentration than the stock solution. So in this example, we will never ever be able to create a concentration higher than 20%. Through dilution, we cannot achieve that. The only way to create a higher concentration of something is to have another stock concentration that is higher than the one that we have now. So in order to create a concentration that is higher than 20%, we would have to have a stock solution of 50, 60% that we can mix together to create this increased concentration. Dilutions are always going to be for the reduction of concentrations. So if you have any questions, please let me know. But our dilutions, they are foundational skills in the lab. We need to understand dilutions as a part of our lab math. And being able to appropriately solve for dilutions is going to save us a lot of time and make sure that our experiments are successful.